Hi everyone, and welcome back to Math 11. So in this section here, we're going to be looking at expanding our knowledge of statistics. So in the first section, we talked about some of the basic definitions like mean, median, mode, range, outliers. And in this case, we're going to see how you can represent this on a graph. So we're going to be looking at frequency tables, histograms, and frequency polygons. So the first example that you see here is what's known as a histogram. So this is a histogram, and it looks like a lot like a bar graph. But notice that this is not a bar graph because if you look at the bottom here, instead of just having a single value for each bar, we have a range of values. So think of it this way: a bar graph would be like percentages for a grade. Let's say there are 2 people with 70%, 3 people with 85%, 4 people with 60%. But then instead of just counting every single percentage, what we can do is kind of group them into letter grades. So we have a range of values. For example, A is from 86 to 100, B is 73 to 85%, right? So instead of having each individual percentage, we can group them into letter grades and we get these intervals. So this is what we have here. We have intervals instead of just single values. So that's what a histogram is. It's kind of like a bar graph, but instead of, again, single values, we have intervals. So each bar here, each bar is an interval of values. Sometimes we also call this a bin because it's like a box that you put a bunch of different values in. Okay, so this is an interval or a bin. And normally there's really no gaps between these bars, or maybe there's a really small gap between the bars. So whenever you make a histogram, you're gonna see that the bars are pretty much next to each other. Unlike a bar graph where you always should have a gap between each bar. At the bottom, on the x-axis, you see the values start from 0 to 10, 10 to 20, 20 to 30, and so on, all the way up to 60. So this is basically showing continuous data. Now you can have continuous or discrete data when you make a histogram. That doesn't really matter, but the point that I'm trying to make here is that for a bar graph, you can have discrete values. You can have 10, then you can have 20, then you can have 30, whereas for a histogram, you can have any values in between. You can have, for example, 0.5, right? That's going to go in the first interval, or you can have 1.3, still going to go in the first interval from 0 to 10. Now, one thing to notice here that normally you don't see these double numbers. You're going to see either 0 and then just 10 here, just because, again, normally there's no gap. So you wouldn't see the numbers repeat like they are shown here, depending on the software they use, depending on the age or the whatever the new style is. Sometimes they show these, sometimes they don't. Normally, nowadays, they don't show double digits like this. So anyway, we see that it goes from 0 all the way up to 60. So from a histogram, we can figure out what the minimum value can be, what the maximum value can be. So in this case, if we look at our data here, it looks like it goes from 0 all the way to 60. So this is going to be my minimum value here from 0, and this is my maximum value. So this tells me that I can have a range that goes from 0 to 60. So if I'm looking to find range, remember, range is going to be the maximum minus the minimum. I can show that my maximum here is 60 minus the minimum, which is 0. So my range is going to be 60. Now, there's no unit, so I don't know what this histogram is about, but I know that the range is 60. The next question is number of intervals or bars. Well, in this case, if you have a histogram, you can just count the bars, right? This is 1, 2, 3, 4, 5, and 6. So in this case, we have 6. Number 3 says width of the bars, or the width of the interval. Now, again, because we already have a graph, we can see that each bar is 10. But what you can also do, once you know the number of bars, right? We have 6 bars in total, or bins, and we know the maximum is 60. What you can do is take your maximum value, divide it by a number of bars. So in this case, it would be 6, and we get our 10. So each interval for each of the bars is going to be 10 units, whatever the units are. Or, of course, again, in this case, we can just look at the graph and see that it goes from 0 to 10, 10 to 20, so each bar is 10 units in width. So what's the point of doing this? Well, like I said, instead of graphing each individual value, we're going to sort them into values that are close to each other. We're going to sort them into groups. So that's why we have these bars, these bins. They're going to put numbers that are close to each other. And we actually decide on the number of intervals we want to have. So here's an example that we have, which examines the, water flow rates in Red River, Manitoba. So as you notice here, it goes from 1950 for the time, for the years, all the way to 1999. And then the second column shows the flow rate in cubic meters per second. Sorry, the units kind of shifted on me here. But anyway, we have all these records from the last 50 years on Red River, Manitoba here. And what I've already highlighted here is the minimum and the maximum. So this is the lowest rate. So this is our minimum. And this is our maximum here. So how do you go from a data like this that you might collect over time, or could be like a lab experiment that you do, and then convert it into something like a histogram? Well, you have to decide on the width of the bars that you're going to have, right? So that will tell you how many bars you're going to have in your histogram. So in order to do that, we need to know our maximum and minimum to find the range. So once you know your range, then we can decide on the width of each of these bars. So the width is going to be defined as the range divided by the number of intervals. Okay? And once you decide and you make your graph, the graph that you obtain, we also call this a frequency distribution. Okay? So let's see what we can do with the raw data that we have here and figure out our bin size. So unfortunately, it's on the next page here. So first, what is the range? So we're going to need our maximum and minimum values. So max minus min. In this case, I already highlighted the maximum and the minimum, which is 4587 for the maximum, and our minimum here is 159, which is again cubic meters per second. So in this case, our range is going to be 4,428. Okay. Now here it says here, suppose that you want to make 10 intervals. Okay. So what is the width? Well, if you want to have 10 intervals, you're going to take our range, 4,428, divided by 10. So take the range. So let me just write range over the number of bars that you want to have. Okay. So again, you had to decide how many bars you want. In this case, the question asks us, let's say we want to have 10 of them. So we're going to take our 4,428, which is our range, divided by 10, and we're going to get 442.8, right? So 442.8 is the exact value, but because we want to put them into ranges of values and we want to pick numbers that are easy to work with, in this case, we're going to round this up to 500, which is still going to include, any values from 0 to 442, and maybe something that's slightly bigger than that. So we're going to approximate the width to be 500. Again, just to make our life easier, and so we can sort them quicker as well. So the next step is to then go to the data table up here, read through all the values for the flow rate, and pick the ones that are between 0 and 500. And this is pretty tedious to do by hand, but you need to understand how it actually works. So we're going to start the first column. I'm going to go through it and see any values that are between 0 and 500. So here's one, right? This is going to be from 0 to 500. So any more? 524 is too big. I'm going to go to the next one, 481, right? That's from 0 to 500. 660 is too big. 510 is too big. 530 is too big. Let's see, 187. That's between 0 and 500. In this case, this one, the minimum, 159. And what else? Anything else in this column? last column we have 396, 280, and I think that's about it. So we have, in total, we have, this is again 0 to 500. This one is 0 to 500. This one is 0 to 500. This one is 0 to 500. We have 1, 2, 3, 4, 5, 6 values which are between 0 to 500 cubic meters per second. So we have 6 of 0 to 500. Now notice the next one goes from 500 to 1000. So that means that we can't include actually the value 500. We had to include anything that's going to be bigger than 500. So okay, just to make a note here, even though the interval stays 500 to 1000, you don't want to say, for example, 501, because depending on the data, you might have continuous data, you might have discrete data. If it's discrete data, you may write 501 because you're counting up by 1. But if it's continuous data, which in this case flow rate can be continuous, you don't want to say it's going to be 501. You just want to leave it as 500, and you have to understand that the 500 goes in the previous interval, not this one. So in this interval, it's going to be anything that's going to be bigger than 500 all the way up to 1000. So again, you're going to go to the our data table here, pick any values that are between 500 and 1000. So again, I'm not going to do this again, but you can do this at home and go through all the values and count them up, how many you're going to end up with. And in this case, I counted to be 11 values for 500 to 1000. And then I counted 9 for 1000 to 1500, 14 for the next one, 5, only 1 between 2500 and 3000, 3. There was no values for 3500 to 4000, and there was no values for 4000 to 4500, and there was only 1 between 4500 and 5000. So if you don't have anything, you're going to include a 0 here because you need to graph this, so you need a value. So you're going to replace it with a 0. So make a note here. So note if there are no values in that interval, okay, you will replace it with 0. So it will be 0. Again, you're going to need this because we need to graph it. Again, the note at the bottom says each interval starts just after the first value in the row and includes the last number. So the last number in each interval is included, whereas the one after it has to be bigger than that number. Okay, so now they have this table now that we kind of condensed information from the original data table. So now we have ranges of values. We counted how many values fall into each of these intervals. So what we can do next is two things. We can create what's known as a histogram, or if you connect just the points from the histogram, we can also make what's known as the frequency polygon. So in this case, at the bottom of this page, we have the histogram. So again, the frequency goes on the y-axis, so it counts how many bins or how many values that fall into this category. So this would be on your y-axis, right? So this is your y-axis, and this is going to be your x-axis. Okay, so that's what we see here in this histogram. So as you can see here, there's only one value shown in the middle, right? You don't have the 0 to 500, 500 to 1000 because it's continuous values. It just shows one. There's a small gap just to see that there's a gap. And we see, for example, from 0 to 500, we have 6 values, right? Here we have, looks like 11. So you should be able to read back all the data from the graph. So here we have 11, And here we see from the graph that it's 11. So anyway, this is a histogram. So we have our bins, we have our intervals, and let's see what else I was going to say. Normally you want to include also the units. So this would be meters cubic per second here. So don't forget that. And of course the title, in this case, the title should be water flow on the Red River. Okay, between the 1950 to 1999. So don't forget the title and your labels. So we have title, we have our labels, frequency, we have flow rate, meters, cubic meters per second here. All right, and again, you're the one who decided on the number of, on the width of each interval. You can make more bins, more intervals if you wanted to. Let's say instead of, we decided to go 500 per interval, but you could have made it 100. You're just gonna end up with more bins. Or you can have 1,000 as your interval. You're gonna have less bins. So it depends on the resolution that you wanna see in your graph, right? If you make the bins really small, you're basically gonna end up with a bar graph because you can make it, you know, only one value per bin, so you end up with a bar graph. But if your interval is wide enough, you end up with a histogram. So you have multiple values per bin. Now, if you take your histogram and instead of making bars, you just take a maximum value, like, let me try to do it here. And let's say put a point on each of these in the middle, normally in the middle, but you can put it on the left or right corner. And then, notice here we have zeros. Instead of making a histogram, what you can do is just make a line graph like this. So if you do this, okay, when there's zero, you're not going to connect the points if there's zero, so you're going to have a gap there. But what we have here now is what's known as a frequency polygon. So this is just another representation of the same data, but instead of having a histogram, we just have the lines. So it's kind of like a line graph, which just connects the peaks of each of the bars. So that's what we have on the next page here. We can also use a frequency distribution table to create a frequency polygon. And again, a frequency polygon is a line graph. It's a type of line graph. So is a line graph produced by joining the midpoints of the intervals using a straight line. So joining the midpoints of the intervals using straight lines. Okay? So if you were to do this by hand and you didn't have a histogram to look at first, like I did here, right? I already had a histogram, so I can just kind of eyeball the midpoint, and you can be pretty accurate with that. If you don't have that, if you just want to have a frequency polygon without having a histogram, you had to actually figure out the midpoint. But that's pretty easy. So for example, if you have your bin from 0 to 500, halfway through is going to be 500 divided by 2, right? So you're going to end up with, again, this would be your 500 divided by 2, which is going to be 250. So your midpoint is going to be 250. Same thing here in the next one. You're going to take the higher value, you're going to take your 1,000 divided by 2. But in this case, you have to add the previous value, right? Because if you just take 500 divided by 2, you're going to end up with, 1,000 divided by 2 is going to be 500. But that's not what we want here. We want to go from 250 to the next value. So you're going to divide the interval, which is 500 divided by 2, plus the value from before. So in this case, you're going to do, again, 500 divided by 2 plus the value from before. So let me write it. 500 divided by 2 plus the maximum from before, plus 500. So in this case, we end up with 750. The next one is going to be 500 divided by 2 plus 1,000. So here we get 1,250. Or what you can think of it this way. Once you find one of them, 250, you're just gonna add 500 each time, right? So you add 500 to this, you get 750, you add 500 to this, you get 1250, and so on, and you're gonna end up with all of these midpoints. So there's a couple of ways you can get these midpoints, but in the end, you're gonna end up with just one single value, which you're gonna connect with a straight line. So here I got 1750, 2250, 2750, 3250, and the last one is 4750. So these are all the midpoints, and again, the frequency still stays the same as before, and again, instead of just having bars, you're going to end up with a line graph. So in this case, they connected the 0, so I normally wouldn't connect the 0 because we only connected the midpoints, but in this graph, they connected 0. So this is, again, float rate, the same thing as before. This is flow rate. On Red River, right, between 1950 to 1999, and the flow rate is still the same units, cubic meters per second, and here we have number of years, or this is your frequency. So the title and the label should be the same as for a histogram, just the graph itself is going to look a little different. So this here is a frequency polygon, but it serves the same purpose as a histogram. Okay, so for practice, let's see. For practice, we're looking at statistical reasoning here, so 5.2, so read pages 213 to 220 and do questions 1, 3, 6, and 11. Now, some of these might take a bit of time, okay, so just take your time, read through each of the data points because you might have to create some of the histogram by hand, and then you can graph it. So again, if you have any questions, make sure you post them as replies on Teams.